Hi, good morning to all. Welcome back to Maths online class. So, we are discussing with the concept volume and we studied how to find the volume of cube and cuboid. Did you practice the questions? Yes, very good. Now, let me wind up the topic of volume with a small topic today. That is, we have studied to find out the volume of cube and cuboid. Now, if we want to find out the volume of any other objects other than cube and cuboid, how can we find out the volume? So, we are discussing about that concept in today's class. Let's see the topic. How can you measure the level of your water? You know how to measure it? Yes, using a measuring cup, you can measure the level of water. So before saying about that, let me take your attention to a small story that which you have already heard. Let's see what is that story. You all of you have heard about this story of this thirsty crow, isn't it? Once a thirsty crow was in search of water. Suddenly it saw a pot, but little of water only in that. It was not able to dip its beak and drink the water. It tried a lot, but not was possible. But did the crow leave it out? No. It thought of an excellent idea. Do you know what was the idea? In order to drink the water, what idea did the crow use? Yes, it picked up some pebbles or stones and dropped in the pot, which helped the crow in raising the water in the pot. Isn't it? Yes, it dropped many stones so that the level of the water raised up and the crow could drink enough of water and get rid of his thirst. We all have read and seen this story, isn't it? The idea used by the crow have a connection with our today's topic. Let's see what is that. So all of you have heard this story, isn't it? The thirsty crow, how it is drinking the water from the pot. What idea it used here? In the pot, it was having only half water and it cannot insert its beak into it and drink. So what it did there? It put some stones in it and the water level increased. Yes, that concept we are using here in order to find out the volume of other solid objects. So let us learn that. For example, if we want to know the volume of a stone or a rock piece, what can we do? Take a beaker of water in which the marking level is there. First take some water. For example, the level of water you have to know, the measurement of the water. And then put the stone in the water. You know the water level increases. The increased water level and what you measured before, the two level, you are having the two measurements. When you subtract these, you will get the volume of the rock or stone piece you have dropped in the water. That means when we drop the rock piece into the water, the volume of the water gets disturbed or raised due to the addition of volume of this rock piece. So that addition, what you added, if you want to know, we have to subtract the level of water what we were having before with the raised level. Let's practice some example questions, then it will be clear to you. Here I am having a beaker and marking level is there in the beaker. You can see 0, 50, 100, 150, 200 ml, etc. Now, I have taken 100 ml of water in the beaker and I want to know the volume of this stone. So, what can I do in order to find out the volume of this stone? I am going to drop this stone into this water. So, without the stone, what was the water level? 100. Now, what happens when I drop the stone? Yes, now the stone is dipped in it. What happens to the water level? Earlier it was only 100, but now it raised to 150, isn't it? So, what made this to increase? Yes, the volume occupied by this stone. So in order to find out the volume of this stone, what we have to do? Earlier the measurement of the water level was 100. Now it raised to 150. So if we subtract this volume, we'll get the volume of the solid or the stone alone. That is, first we mark the volume of water as 100 ml. Now we took volume of water with stone, we got 150 ml. So the volume of the stone alone will be give 150 minus 100, that is 50 ml. In order to apply this method of finding the volume, we need to understand one relation. What is that? The liquid items such as water, juice, etc. are measured in liter, milliliter, etc. So how can we connect this with solid items? There you should know one relation. That is, 1 milliliter is equal to 1 cubic centimeter. What is 1 milliliter is equal to 1 cubic centimeter. So, if we are measuring the water level using 100 liter or 100 milliliters, then we can assume that this 100 milliliter is equal to 100 cubic centimeter. So, we can find out the volume of solid objects. One example. So, we know the relation 1 ml is equal to 1 cubic centimeter, isn't it? The liquid and all we are measuring in ml, but we are finding the volume of what? Solid objects. So that cannot be marked or measured in ml. So that we need in what? Centimeter or meter. For that 1 ml, we are treating the equation 1 ml as 1 cubic centimeter. So in the earlier example, what we did? There we got the volume of the stone as 50 ml, isn't it? So there it can be considered as 50 cubic centimeter. So what is the volume of the stone? 50 cubic centimeter. In this way, we can find out the volume of other solid objects. So here I took 100 ml of water in a measuring water level. So the level of water is 100 ml. When I drop the stone or rock piece into this water, the level increased up to 150. So what is the new level? 150. Before putting the rock, it was 100 ml. After inserting the rock piece, it rises to 150. So what will be the volume of the rock? 150 minus 100. What it is? 50. Now you know 1 ml is 1 cubic centimeter. So 50 ml equal to 50 cubic centimeter. So the volume of that rock piece is 50 cubic centimeter. In this way you can find out the volume of solid objects. Let's see some more examples. Now we can solve some example questions. Solids of different shapes are doped in measuring cylinder with 100 ml of water. Find volume of solids. That means I'm dropping 4 solids in water. All the time the first water level was 100 ml itself. So I need to find out the volume of each solid. First one, so the water level first I was having 100 ml. Now I am going to first drop a solid. Here I have dropped a solid. I think it is a small ball. It's anyway the picture is not clear. It's a textbook. It's a question from your textbook. First I thought maybe watermelon, but I think it's not. It's what I don't know. Anyway, yes, I'm considering it as a solid. So a solid has dropped in the water. Earlier it was 100 ml. Now to what extent the water level increased? 120. So first the water level was 100 ml. Now the water level is 120. So how can we find the volume of this solid? So the volume of water is 100 ml. Now when we drop the solid in it, the volume raised to how much? 120 ml. So we want to find out the volume of solid alone. So water level raised 120, 100 It was earlier 100, it raised to 120. So that raised 120 minus what was the first volume? 100. So 120 minus 100, 20 ml. Now you have studied the relation 1 ml is equal to 1 cubic centimeter. So the volume of the solid is 20 cubic centimeter. That is, we know the volume of a solid and all we are measuring in cubic centimeter. So the volume of solid is 20 cubic centimeter. Now secondly, I am dropping a potato. Is it potato itself? Let us hope so. So again the first water level we are considering 100 ml itself. After inserting the potato, the level increased to 140. So how can we find the volume of this solid? In all the questions, the volume of water first level is 100 ml itself. Now here we dropped the solid. Now what is it? Where it raised to 140 ml. That when we drop the solid, the water level increased to 140 ml. So we want the volume of solid alone, that is equal to 140 minus 100, 40 ml. Now taking the relation, 40 ml can be written as 40 cubic centimeter. So what is the volume of solid? 40 cubic centimeter. So this time we are inserting a rubber, that means eraser. So the first water level was 100. Then after inserting the rubber, the water level increased to 110 ml. Now how can I find the volume of this rubber? Here also volume of the water first is 100 ml. Then we dropped the solid rubber. Volume of water with solid is 110 ml. Therefore the volume of the solid, that is rubber, is 110 minus 100, 10 ml. Now rubber is a solid, so 10 cubic centimeter. So the volume of the rubber is 10 cubic centimeter. So what is that relation? 1 ml is equal to 1 cubic centimeter. So 10 ml will be equal to 10 cubic centimeter itself. Lastly, I am dropping a piece of stone. Now, up to where the water level have increased? First, it was having only 100 ml. All the cases, the water level first was 100 ml. After dropping, we are having different. So, after dropping the stone, the level increased to 200 ml. So, what is the volume of this stone? Let us find it. The last one, again the volume of the water level first was 100 ml itself. Then we dropped a stone. Then the volume of water level increased to from 100 to 200 ml. So the level of water was 200 ml with solid. So volume of the solid is 200 ml minus 100 ml, which gives you 100 ml. Now we are finding the volume of a solid. So ml cannot be given, isn't it? So 100 ml equal to 100 cubic centimeter. Why? We know 1 ml is equal to 1 cubic centimeters. Therefore, the volume of the stone is 100 cubic centimeter. So let's conclude today's class. Today we covered a small topic on volume of other solid objects. Anyway, this method cannot be considered as the accurate method because we cannot say this is the correct volume of that solid objects. We can approximately find out the volume. By finding out the volume of cube and cuboid by formulas, we can say that are accurate values. These all are, we can say, approximate volume of the solid objects. Anyway, that is how we are finding the volume of other solid objects. Copy down the notes given and attend the test paper. The chapter Perimeter, Area and Volume has come to an end. The concept regarding area, perimeter and volume has been covered. Now you can practice more questions and clear your doubts. We'll meet with the other chapter in another video. Thank you.